All right, here we are at number 12, and the directions are to solve the system by substitution or elimination. And the system they've given us is 3x minus 13 equals negative y for equation 1, and 2x plus 9y equals negative 8 for equation 2. And I think for number 12, I'm going to use substitution to solve. And the reason I want to use substitution is because if we look at the first equation here, we're almost solved for y. And if we're almost solved for x or y, substitution is probably the easier of the two to use. So let's go ahead and start by first rewriting both of our equations. And 2x plus 9y equals negative 8. All right, so to solve for y here in equation 1, all we're going to do is, let's go ahead and multiply the entire equation by negative 1. And all that does is change each and every one of the signs. So now instead of a negative y, we'll have a positive y. Instead of positive 3x, we'll now have a negative 3x. And then instead of negative 13, we'll now have a positive 13. And now we've solved for y with equation 1. And since we're using substitution, we're going to go ahead and take this value of y and plug it into equation 2 wherever we see a y. Because we're now saying this is what the value of y is. So let's go ahead and rewrite equation number 2, except we're going to now take out the y and plug in the value of y. So 2x plus 9. Now we're taking out y, plugging in the value of y. So negative 3x plus 13 equals negative 8. And now we'll go ahead and distribute this negative 9 through as we clean up the second equation, or second line here rather. So we have 2x, and now 9 times negative 3x is minus 27x. Positive 9 times positive 13 is going to give us plus 117 equals negative 8. And let's go ahead and combine some like terms here. So positive 2x minus 27x gives us negative 25x plus 117 equals negative 8. And we want to solve for x. Let's go ahead and move that constant over. So we'll subtract 117 from both sides, leaving us with negative 25x equals negative 125. And lastly here, we'll divide by negative 25 on both sides, and that'll leave us with x equals, and now positive 5. All right, so we've now solved for x. X is now a real number. It's no longer an expression or an equation. So let's go ahead now and take this value and plug it back in to what we originally solved for, which was y. Because now that we have a real value for x, as soon as we take this value of x, plug it in to the now y equation, we'll have our y value. You could absolutely take this x value and plug it back into one of your two original equations, but when you do this, you have a little bit more work to do, because here you still have to solve for y again. Here you'd have a couple steps in order to actually solve for y, but here, if we take our value, plug it in, we've already got y all by itself. So let's see what happens. Y equals negative 3. We're now going to plug in the value of x plus 13. So y equals negative 15 plus 13. And finally here, y equals, well, negative 15 plus 13 is going to give us negative 2. And so there we have it. We now have solved for x, we've solved for y. And it's a good idea to go ahead and write your answer as an ordered pair. So 5, negative 2, right? This is our x, this is our y. And I mentioned in the introduction video, if you watched the introduction to this final exam review series, that I would mention which problems you can, quote unquote, check yourself, meaning you'll know whether or not you got the right answer before walking out the door on test day, because what you can do to check yourself to make sure that the solution is in fact 5, negative 2, is take each of these values, plug it back into your original equation and see what happens. So what do I mean by that? You should get a true statement. So let's go ahead and take 5 and negative 2, plug it back into the first equation, and see if we get a true statement. So here we have 3 times, and now the value of x, so 5, minus 13 equals negative, and now plug in the value of y, so negative 2. Well, here we have 15 minus 13, right? So 15 minus 13 is positive 2 equals, and then when we distribute this negative through, we get positive 2. So does 2 equal 2? Well, yeah, that's a true statement. So we know that the solution works for our first equation. And if we check it with the second equation, you'll also see that it works. And if the solution works for both of your equations, then it is a solution to the system. If you take your solution, plug it into both equations, and it's only true for one and not the other, then your solution is incorrect. You have to derive a solution that works for both equations, and in this case 5 negative 2 would work, but for the sake of time I'm not going to plug it in here. But this is what I mean by make sure that you are checking your answers on those problems that you're able to, because if you were to plug in and you got the wrong answer, meaning you took your solution, plugged it in, and you got a false answer, well then go back and check your work. Maybe you had a little sign error somewhere. All right, but for a lot of these, you'll be able to check yourself and know how you did before leaving the test. At any rate, number 12, the solution is 5 negative 2. All right, let's take a look at number 13. I'll see you there.